So hello everyone, and welcome to PyCon 2019. It's great to be here. So my name is Allyn Hunt, and I'm going to be talking about adding data visualization to your Flask app with React and an amazing library, React Victory Charts. So this is me. You can get in touch with me if you like on any of these. I'll be posting the code to my GitHub this afternoon. I'm an engineer by trade. I play a lot of video games, so that's kind of how I got involved with a lot of this stuff. So you can see some of the previous products I've worked on. I played a lot of Destiny, the video game. So for Destiny and Destiny 2, I made an inventory management transfer app. So within the game, if you're playing it, if you wanted to change a piece of armor or a helmet or your weapon, you can click on any of those pictures and it'll transfer the items within game. And the app itself was pretty basic, but the kind of idea for the app was that it was a series of blog posts and you could build your own application along with it. There was a bunch of people in the Destiny community, and particularly in the Destiny development community, who were sharing knowledge, and I was kind of involved in that. So at PyCon UK 2017, I presented that in PyCon Ireland in 2018, and actually in PyCon Limerick this year as well, I was able to present some of the other stuff I'd been working on. So moving on from the Destiny Vault Reader app, I added some asynchronous tasks to that. So whenever the Destiny manifest would change, I added some asynchronous tasks to automatically load all of the Destiny content into a Redis database. So I had a talk on Redis and Celery asynchronous workers, some cool stuff you could do with databases. So for work, for example, I've built a lot of web applications that scrape data from multiple servers. So for an example, if you're in an environment where you have 10 or 12 servers, how do you use the same database and the same Flask application and reuse all that code? And I kind of touched on some of the React and jQuery stuff in that talk, but at that stage it was all kind of pretty new to me as well. So I've since done another few projects with it. So I'm going to talk to you about what I've been working on recently. So our Flask application. So we're going to talk about the project setup. This is the first part of the, I think, three parts. So we'll start on the Flask project setup, how we store data in a database, and how we create app blueprints, and what an app blueprint actually is. And for the technology stack for this, Python, on the server side is Python with Flask and SQL Alchemy. SQL Alchemy is an object relational mapper. So you don't need to handle any of the SQL stuff yourself. SQL Alchemy has really nice, clean syntax for handling that. And for the app structure, we're kind of going to come at this from a project that's already pretty established. So rather than kind of building everything from the ground up, and normally what I would do anyway was I'd clone Miguel Grinberg's microblog app. Some of you may have heard of Miguel. He actually did the keynote talk last year at PyCon Ireland, so you may have seen him there. He literally wrote the book on Flask applications, and he has a series of blog posts and tutorials online. So if you're interested in Flask, you've probably seen Miguel's stuff already. And from the front end, so we're going to be using npm install React Victory Charts. We'll use Webpack and Babel as well. And I'll talk about some of those. There's actually, I will talk about Webpack, but I believe there's a talk on setting up Webpack for your projects this afternoon, I think at 3 o'clock. So I'll be attending that myself. So if you've never built a web application, web applications are pretty fun. They can be a bit daunting to start out with, but for Flask, you can build a web application with 5 lines of code. So it's pretty easy to get stuck in. Once you get stuck in and you start working on more established projects, and this is what we'll be using on the left-hand side there. So this is the microblog project structure. And this is your typical kind of Flask project structure for a large-scale application. So we'll be working from that perspective. So I'll give you, this is what the project structure looks like, and we'll talk to some of those things here. So for example, your database definition will be in your config.py. So that's where you create your database and you attach it to your application. Your database models will be created in models.py. So that's where you define what your database tables are going to be, what data types to have, how many columns to have, for example. Your API root and your config for your API will obviously be in the API directory here. And we're going to add the React front end into the static directory. So right now there's nothing in the static directory, but we'll build up the directory structure and all the files we need for using React. So if you've used Python for any amount of time, you'll probably be kind of familiar with these type of data structures on the right-hand side here. So you can see this is the example data we're going to be using for this project. So it's a company, the company details there. So we have the business type, the company name is Stark Industries, and Pepper Potts is the CEO. We have a list of kind of financial details for the company. So we have a Python dictionary, and inside the Python dictionary we have another object, a Python dictionary, which has a list of 4 different dictionaries there. And again, how do we display this type of data? I think if you've ever worked on any web applications before, we're probably all kind of sick to the back teeth of Bootstrap and putting all the hard work into creating a database and loading the database with data and then sticking the data into a table and having someone kind of look at it and kind of shrug their shoulders. So we'll look at how we can take this data and make it look pretty cool. So, and again, so we've talked about the directory or the data structure on the left-hand side. So when I create a Python dictionary, my favorite thing to do with dictionaries is, of course, nest them inside other dictionaries. So instead of having one big data set, you have a huge, massive data set with lots of data sets listed inside it. So as you can see on the left-hand side, we have a finance list that has 4 dictionaries. And then on the right-hand side, we have that whole company, and I've kind of hidden the finance bit there. So we have a list of company dictionaries. So your data kind of spirals out of control a bit. It gets a bit difficult to present that data out to. For me, though, when I'm working with that data, I generally find it's easy to look at the data and interpret it and find relationships between kind of what's going on. I don't think my boss sees like that when I try and present the data. So something invariably gets lost in translation when you have this kind of big wall of text and you're expecting people to interpret kind of what's going on inside of it. So here's kind of a more structured type of data. So this is our SQL database, and this is what we're going to look to build here. So you can look at this from the top down or from the bottom up. So we have a list of finance objects on the bottom, and each finance object is connected to a company table. So that's a many-to-one relationship, or sorry, it's a one-to-many relationship. So we have one company with many finance objects. So let's look at how we can take our data and build an SQL object like that. Okay, so first thing we're going to do, we'll start from the bottom up from this perspective. So we'll start with the finance items, and we'll create the finance model. So in our models.py, this is how we'd create a model in SQL Alchemy. So it's pretty intuitive there. So we have a couple of columns there. So we have an ID column, a year column, 4 earnings columns. So you can see from that the ID is an integer type and it's a primary key. The year is an integer type. It defaults to 1999. It's pretty intuitive to see. The company ID is an integer and it's a foreign key, and it's related to a company table.id. So the ID part of a company table. So we've created the model. How do we use the model? And this is how we create some finance objects. So we have a model of type finance, and we create an instance, Stark Finance Y1. There's a lot of text there. You don't need to understand everything, but just kind of getting the general understanding behind it. So we're creating one object, which is Stark Finance Year 1 of type finance model. We're creating 4 of them, so Stark Finance Year 4 would be the 4th of them. And what we can do with those models, or those objects of finance models, is we can just create a list of them. So it's pretty easy so far. That's how we'd write it in our application code. So that's our finance objects, the 4 finance objects. Now we want to create a company object. So again, we define the company model in our models.py. Again, pretty easy. There's 4 columns here, integers and strings. So the names are obviously strings with 140 characters. The ID is a primary key. But on the bottom here, we have a finances column. And the finance column is of type database relationship, and it has a relationship to the finance table that we just created. And the lazy dynamic kind of handles the foreign key relationship for us, so we don't need to do anything. So now how do we create an instance of a company? So my company equals an instance of the company model that we just created there, and we can populate it there. So from our Python dictionary of our data, Stark company, the company name, the company CEO's name and the business type. And then finances, then we give it the list of finances. So we don't need to add each finance item one by one. And what we've done there is we've created one instance of the company object, a very specific instance, so our Stark Industries company. And we've added a full list of finances to that, so we can have as many as we wanted. We add that to our database and then we commit it. So you can see here, so if we actually look inside our database, what have we actually done now? So we've got, on the very top image there, so item number 2 is Stark Industries with the CEO, Pepper Potts. And we can see on the bottom here for the finances table, we've created 4 objects in our finances table, or 4 entries into our finances table. And on the bottom here, you can see the relationship, so they're attached to company number 2. So easy peasy, we have our table built. Sometimes the code doesn't work out like that. So for example, if I was to have already created a company object and after the fact I wanted to go back and add a bunch of finance objects to the table, we could easily do that as well. So we create a company object here. I've just done that. I didn't add a list of finance objects to it here, but what we can just do on the bottom 2 lines here, we can, after the fact, we can just append new items to that. So if that company object was to grow with more years of finance data being added to it, this is how we do it. We just append it onto that. So our database is looking pretty good right now. Let's look at how do we connect that to our API. And probably the easiest way to do that will be with a blueprint. So what a blueprint is essentially a way of sectioning off your application into different functionality. So for a typical Flask application, you would probably have unauthorized endpoints. The user doesn't need to be logged in to access those. Authorized endpoints where the user does need to be logged in. And we have our API endpoints. And more often than not, you need to be authorized as well to use the API endpoints. So the user sends a request and we'd send a response of either one response made up of many of these, or else we could send multiple responses back to the user. So again, this is how you set up the blueprint. It's a bit of a wall of text. You don't need to read and understand every kind of line of text here, but I'll kind of point out some of the important ones. So on the top left is where we actually create the blueprint. On the bottom is where we attach the blueprint to our API. We attach the blueprint to our app. And you can see on the very last line on the bottom left, I've given it a URL prefix. So whenever anyone wants to talk to our API, the URL is prefixed with API 1_0. And in our API routes, this is how we'd actually create an API endpoint. So when someone sends a request to our server, this is how we'd handle that request, and we'd send a response back to them. So you can see the very first line, it says get company, and it takes an integer of an ID. So company number 1 will be Stark International, company number 2 will be Wayne-Corr. And on the 4th line there, we actually do our SQL query. So C equals company.query.filter by, and we give it the ID. And we create a Python dictionary, and we send back the response, and we JSONify the response, which is a JavaScript object notation. So it's essentially the JavaScript equivalent to a Python dictionary, and we send that back with the status code. So hopefully the status code will be 200, and everything will be okay. But we look into actually doing some error handling as well a little bit after this. So how do we test our API endpoint? So testing the API endpoint, we can do it with Chrome. If you visit the URL we just defined, so if you remember, we prefix the URL with API 1_0, and get company 1, you can see we've got Bruce Wayne at Wayne-Corr. So all the Chrome can handle the JSON response as well, and it can display it. So the values are now coming from our database, and our API is now up and running. So easy peasy again. So what have we done so far? So right now, all we've done is we've created a web application. The web application can send HTML web pages, but it can also send JSON response from API calls. So it's a good start. And from that, then we'll look into adding a React frontend. So if you've worked on building web applications, you're probably already at the stage anyway where you've got a web application up and going. You may or may not have an API calls up and going. For Flask, it's pretty easy to get it up and going. Pretty much all of the React front-end is agnostic to whatever system you're using. So if you're using Django or Flask, this should be applicable to you. So why do we need JavaScript? If you can do everything on the server, why would you bother doing it on the front end, or why would you add the kind of the hassle of building a web front end or a JavaScript front end? The main reason being, if you have a lot of content on your page, you don't want to reload all that content every time the user sends a request to you. If something very small in the page content part was to change, you wouldn't want to have to redraw all the graphs or redraw the page content. You just want to update that small section of it. So you want to create a kind of a more modular application that's more interactive for the users. And you don't want the user sitting there, refreshing the page every kind of 2 or 3 seconds and waiting 2 or 3 seconds for a huge amount of data to be sent. You want all of these things to be updated in the background. So rather than updating the full page, just update one div of the page. And for the React front end, again, so this is the file structure I touched on we were going to build inside. So there's not too much in it, and a lot of these files, you don't really need to kind of understand fully what goes into them. And I'll try and point out just the key items that's worth looking at. So in the top 3 files are created in our Webpack and Babel config. The bundle.js is the Webpack and Babel output code. So that's the code that's actually loaded when you visit a web page. And the scripts directory, everything inside the scripts directory is the React code we actually write. So we write the React code, Webpack takes it, it bundles it up, and it sends it to the user. So with that, what is Webpack? So if you've never heard of Webpack before, it's defined as being a module bundler. So it essentially, if you have 5 JavaScript files, Webpack will load all those. It'll bundle all of those JavaScript files together into one file. So rather than having to send 5 responses with 5 different JavaScript files, you'd only send one response. It'll also bundle up your CSS. It can bundle your images and other files. So it just makes things a lot easier and a lot easier to use. But it can also minimize your code and do a lot of other optimizing your code. So it's very, very important to have. So how do you set up Webpack? So there's 3 commands there, and the 3 commands are npm init, you initialize your project, install Webpack, so npm I Webpack, so you're installing Webpack, and you install the Webpack CLI. So it's not too much to it just yet. We'll need to create the following files as well. We need to create npm init creates the package.json, we'll edit that, and we need to create the Webpack config, so we look at that as well. So next up then is Babel, and what is Babel? So Babel essentially transpiles or transforms code. So if we want to use React, we want to use the React library, React isn't vanilla JavaScript, so it needs to go through some transformation before the web browser understands how to use your React code. So for the example on the left, you can see n arrow n **2. So that's what's termed as an arrow function. And you can see on the right-hand side here, it's function, and in brackets n takes the parameter n. So it's a much cleaner syntax on the left. So we want to be able to take all of the newest and latest and greatest JavaScript features and kind of backport them into the current browsers that we have. So how do we install Babel? It's just 4 lines. So, well, it's actually 1 line of code. You can split it into 4 if you want. So first of all, we install the Babel core, the Babel loader, the Babel presets and presets for React. So the Babel core is the actual the core of the compiler. Babel loader connects it with Webpack and tells Webpack that you want to transpile this code and how to transpile it and which files to transpile. Babel presets takes the newer JavaScript code and transpiles it back to ES5 code, which is a language that's readily understood by most web browsers. And the React presets is obviously, it takes the React code and the React.js code and transpiles it into generic JavaScript that any browser can read. We're nearly there with the installs. So obviously then we've gone through the project setup. We want to install React and React DOM, and we want to install victory charts. So React is the React core, and React DOM allows React to interact with any of the DOM elements. So if you want to identify a div and change the value of the div or something like that, or you want to render something into a certain place on your HTML DOM. Yeah, so this is a bit of an eye chart, but you don't really need to read all of this. So when you set up Webpack, you need to set up your package.json file. The majority of this file is, you type it in when you do npm init, so you give it your name, you give it your GitHub repo, you can put some keywords in, so Flask, React.js, and on the bottom then it has some of the dependencies that you've just installed. So again, we've just installed Webpack, we've just installed Victory and Babel, so they're all listed there. The main thing to look at here though is your scripts. So how do you run Webpack? So you have 3 different commands there. To be honest with you, I only use 2 commands. I use build and watch. The dev build is a bit redundant. Build if you want to build it for production. Watch if you're actually in development. And every time you save a file, you want the Webpack to update your the contents. And here is your Webpack config.js. So again, there's not too much in this, but it's just important to note a couple of things. Your entry file, which is your index.js, we're going to write that file in the next few files, so we'll talk about that after. Your bundle.js, so that's the output of Webpack, and it's stored in the dist directory. And the next section here, the JSX and JS files. So we're going to use Babel loader for JavaScript and JavaScript JSX format files. And if anything was a bit confusing there at all, if you just do webpack --help, you get a list of all the items there. So you can see on the bottom there we have --watch. Actually tells you what happens when you type that in. -p for production. When you run -p, it automatically optimizes and minimizes your code. So there's a couple of handy little features like that that it talks to. Okay, so now we have everything installed, and we actually want to start writing React code. So our project is set up. So in the directory structure above, you can see, so in our static scripts folder, we're going to create a hello world.js file. So the content of this file is taken exactly from the React documents on the React homepage. So all we're going to do there, and you can see inside that, so we have a class of hello world, which is of type React component. So we're creating a React component called hello world. The render function is the only function that, it's a built-in function on React components, and it's the only function that's actually required for React. And all that render function is going to do is return a heading that says hello world. So it's not too much there. The index.js file, as we talked to previously, that's our entry point. So that's how we bundle our files together. This is the file we tell Webpack to transpile. Or Webpack can be able to transpile. So you can see there, so we import React DOM because we actually want to React to modify the DOM. And we import the hello world. And at the very bottom line, we take our hello world component, we look for a component with the ID of React root, and then we populate it with the contents of the hello world render above there. So it's going to be one heading. And just before we can run that code, we need to update our Flask setup. So how do you update your Flask setup? So in any of your templates, so you can do this on any of your HTML pages, or you can do it on your base.html, and it'll be copied across to all of your templates from then. So you just add a div with the ID of React root, and you add the source. So the source is it's stored in the dist bundle.js in the static folder. So one line of JavaScript and one line of HTML there. So this is us. So when you view your React app, there you go, hello world. There's not too much to it. Everything on the top of here, the microblog, home, explore, search, that's all built off Miguel's project. So if you're integrating this into an existing project, you'd have your own nav bar, you'd have your own divs there, however, but this is a good start for us. So there's not much there, but it's working right now. So let's look on expanding that. So again, if we look at that hello world example, and again, I went back to the React documents, and I've taken their API code. So this code on the right, it's a bit big, but there's not too much more into it than what was on the left. So I'll talk through what we've added. So we've added a constructor. The constructor stores the state of our application. So you can see there, this.state items is an empty array. So that's where our state is going to be stored. It also has some error handling and it tells you if the page has been loaded. Component did mount is a React built-in function. And it's one of the first functions that's called when React renders a web page. So if you want to render a web page, you want to make an API call, this is how you do it. So I've put my API URL in there, but I think that's the only thing I've changed from the React documents. And then we've updated the render slightly. So we've added some error handling there, and we've added a checker to see if the page is loaded or not. So you can see from the component did mount, we set error if the response of the fetch has an error state. So if there was a 404, we'd send an error, and we wouldn't render anything. We'd just render our error message down at the bottom. And as you can see, there's nothing actually in the render yet. So if it's loading, it'll tell you it's loading, else there's nothing there. So we'll populate that now. And this is just a kind of a quick way of how do you populate your URL parameters. Normally, if you're creating a web application, you probably have a web form of some sort, or you would, you'd have a button that you'd click on, and it would take these parameters from a div, for example. But if you wanted to copy the code I'm working with, you can actually take the URL. So from your HTML URL, you can actually populate your API URL. The way I've done it there. Okay, so what have we done so far? So we've created our Flask application. We've done a React setup, and we've added a very basic React API to our application. So pretty good so far. We're making good progress. So now let's look at making a kind of a very basic victory chart. So from that, then we can actually have a look at some of the other charts. If you don't know what victory charts are, this is what they look like. I think I actually have it up here. So I didn't use this to make my Destiny presentation. So I kind of touched on a lot of the stuff. When I was working with Destiny, I don't know if you play Destiny. Let's say if you pull your inventory items, you might have about 200 items up there. And every time you transfer one of the items, you have to re-render the whole page. And I kind of got very frustrated with that. So I myself started using dim and a couple of the other ones, because even though I built my own application, they're just a lot smoother. So I started looking into kind of adding a React front end and how could I kind of improve it. And I was involved with some of the, I was communicating with some of the dim developers who were adding React to dim at that time, and some of the other guys. What I've used victory charts for was I write a lot of applications and work as well. So I pull data from a server, and like that I try to present the data out, but it's very difficult to do that. It's very, very easy to integrate victory apps into your application. Yeah, so I couldn't get the web page up and going because I'm presenting here, but a lot of these charts they're very interactive, they're all animated, and they're very easy to get up and going. So we'll have a look at some of them now. So this is what we're going to look at. So we have our API endpoint. So once we make a request to our API endpoint, we can send a response back. So we've looked at the Python dictionary response. So this is the JSON response from the Chrome developer tools that our React API gets, our React app receives. And this is the chart we're going to make in this example here. So it's a pretty basic chart, but you can see from some of the victory examples there, we can do a lot more with it. So we'll go step by step on how we actually go through this. So victory bar. So in our React app, in the render section of it, we add a victory bar, which, because we've installed victory, we can include it like you would any other module. So from victory, import victory bar from victory. So here you can see we're passing the data parameter. We're just passing in an array of data. So there's 4 items in the array, and these are the values. And it straight away renders up 4 bars. And it's a bit basic. The values are correct, but it doesn't really tell us much. But I think it's pretty powerful that you can get a chart up with kind of 1 line of code or 2 lines of code. So the next step from that will be to add some accesses to the bar. So you can see we have a horizontal and vertical axis there. We're giving the chart some sort of concept of scale as well. It doesn't look perfect at the moment because you can see some of the items on the left are getting cut off. The first bar is actually on the axis. That's not really a mistake because victory is very customizable. So rather than trying to render a bar, you could be trying to render a point and create kind of a line chart from that. So victory is very customizable, but you do have to do a little bit more work to actually tell it specifically what it is you want to do. Yeah, so we have two components there. So we have victory access, and from the victory access, we're giving it another array, and the array is essentially Q1, Q2, Q3, Q4. So we're just giving it an array that tells it what the horizontal axis is. And from the data, the finance data, it's populating the vertical axis. On the next item there, it says victory axis, dependent axis. That essentially populates the vertical axis. And there's a bit of JSX up there, and all that does is it takes the values, divides them by 1,000,000, and puts a dollar in front of them and puts an M at the end of it. So not too much, just kind of text formatting really. And here we go. So this is our victory chart built and rendered. So the last diagram we had, everything was kind of a bit skewed over here. You can see that the first bar was exactly on the horizontal axis. So what we've done is we've added some padding just to move that across. So on the third line there, it says domain padding equals 20. That padding just pulls everything across and makes it a bit more readable. On the second line there, where it says padding left, right, bottom, top, we've just added a bit of padding around the chart. So now that we can actually see the numbers on the left, for example, aren't getting cut off anymore. Sometimes the numbers on the bottom can get cut off. There's a bit of a fiddling about what you have to do with these when you integrate them into your application. So it's very difficult to actually add height and width, for example, to the chart. The charts don't really work like that. What the victory chart will try and do is it'll expand itself as much as possible to take up all of the room in the containing div. So essentially what you'd need to do for this is create a wrapper div and give the wrapper div some sort of a hard-coded max and min height and max and min width to actually to contain the chart. There are a lot of parameters there, so you can see I'm adding padding top, right, and left, bottom. There are a lot of features that you can add with Victory, but some of them can be a bit tricky, and some of them are not as intuitive as you would expect. We're also adding Victory Stack, and what does Victory Stack do? So we're wrapping the Victory bar with Victory Stack, and Victory Stack just gives it some of these nice preset color scales. So you can have warm, you can have cool, which is a nice kind of blue color. You can have grayscale. And you'd seen on the previous slide I gave, one of the examples, you had different kind of bars stacked on top of each other. So you can create different instances of Victory bar with different color scales attached to it, so you can compare different types of data as well. So, well, yeah, just to jump back to this. So this is the basic Victory chart rendered. So we've sent the data in, and all we're essentially doing is we've taken our JSON data and we've split it into 2 arrays. We didn't really need to split it into 2 arrays. We could do a bit of JavaScript on it to actually take it as it is, but it looks a bit kind of cleaner when you have an array for the horizontal axis and an array for the vertical axis. And we've populated the chart with that. So to jump onto that, so how would you create some other charts? So if we look at this kind of Victory box plot, so this isn't coming from the data we have in our app, but I just wanted to point out, actually this chart can be recreated in 3 lines of code. So everything you're seeing here on the right-hand side is just kind of some nice styling. So the kind of all the style section there is just adding in some nice colors. The data is hard-coded in there. But I think we can see, from example, from the data structure, we could easily recreate that in Python and send that across our API and populate it directly into here. Parameters like Victory min label, max label, all they're doing is they're adding a little tick on the top and bottom of the chart for the min values. So for example, the very left-hand bar there has a max value of 5 and a min value of 1. So it's not required either. The chart will render very well without those. You don't need any of the style data at all to render this. Okay, so what have we done so far? So we have our HTML application in Flask. We have an API call with React that will now populate our chart. And we've installed and rendered our first Victory chart. So I think I'm probably a bit ahead of schedule here. So what do we do next? Probably the next item we want to do is secure our API. So just a couple of tips and tricks for that. So can anyone spot the deliberate mistake in this wall of text? There's 2 walls of text there. There's no prize. Yeah, it's pretty tricky. I'd be very surprised if anyone gets it. So on the top, the very first line of both routes, you can see on the very left-hand side, we're not defining the ID as an integer, and on the right-hand side, we are defining the ID as an integer. And that's a big problem, really, because the user or anyone can send whatever value they want in there. So you can see that the value of ID is taken straight away. We put it into an SQL query, and we send it off to our database. So if we're not sanitizing that data, it leaves us open to SQL injections or a lot of trouble, really. And essentially, probably a lot of negative user interface. If people are sending the wrong data as well, they're just going to be constantly hitting 404s. So there's a lot we can do in that to check it first. But the first thing we need to do is we need to be checking for types. So for example, if you check for an integer here, people can't send you a string. They'll just hit a 404. And you can do something like that. Okay, that's not real. That's not a real SQL injection attack. But if you Google Flask filter by and SQL injection, you'll see there are actually some good examples of how to actually inject this type of code. The problem here is the filter by function. It takes kind of a keyword value, so ID equals ID, but it will also accept raw SQL. And that's an issue here, because if someone sends a string onto that and you don't sanitize that data, you push that into your function there, you're going to be injecting whatever the user wants into that. So it looks nice and tidy there, but the user can send raw SQL to that, and you can get unintended consequences from that. There's also, before we even get to the filter by, before we actually even query our database, we should be doing some sort of sanitizing. So you can actually call your database first and check, for example, the size. So if the user is looking for company number 500 and you've only got 200 companies, then maybe you shouldn't do that. And try not to accept strings at all, if at all possible. You don't really want to be doing that. Try to uniqueify, for example, if you had a company, try uniqueify each company with an ID. Don't accept strings, because that's just going to leave you getting into trouble. So Shine, I have 5 questions left. If anyone has any questions, if not, you can catch me there. That's my Twitter and email handle. And on my GitHub, I will try and push the code as soon as possible. I was working on it last night, so I didn't push it. But I suppose I should probably be looking at some of the best practices and push it now, and maybe do a commit later on and clean it up. So maybe I'll do that.